Hello everyone, this is Dr. Sehlaoui. I just want to share with you this brief introduction to educational research, which I hope you can find helpful as you start to think about your um, reflective inquiry project in this class. The first thing that you need to understand is the nature of research and what do we mean by research. So, for example, research is not just a matter of gathering information, moving it from one place to another. It's a systematic process and it involves some steps. And I have summarized these for you in 8 points. And feel free to check this website for more information on that. Okay, so it's very important to understand these steps and come back to them again as you wish and as you need so that you can understand what research is. On that number 8, it says research can be structural or cyclical, and we will see in a minute on slides 8 and 9 how that works. The purpose of doing educational research. This is very important, and I would like you to start thinking about this as a professional. I picked this quote from Lather, and she made an excellent point. And the quote reminds me of folks who limit scientific research to quantitative research only. There is quantitative research and there is qualitative research. And in my research, for example, I refer to the need for educators to use and develop the language of critique and the language of possibility through their educational research. So it doesn't matter whether you take the quantitative route or the qualitative route or alternative in the research methodology, or you combine both. You use what is called the mixed methodology. In order to speak these languages that I've referred to here, educators need to be critical consumers and producers of research with an ultimate goal of changing and improving the profession. But unfortunately, as you know, most teachers and educators are consumers of research. The two languages that I refer to here can be defined as the teacher's ability. The first one, which is the language of critique, is the teacher's ability to defend themselves pedagogically in front of their peers, parents, educators, other educators, or administrators. The language of possibility refers to that next step, which is the teacher's ability to use their language of critique to bring about change. For more on these two languages and how they are applied in the classroom, I would like you to check that resource listed right here. I think on page 12 or 11 and 12 or 12, 13, you will find a VNet, a classroom scenario where the two languages have been applied. Purposes of educational research. To me, educational research should consist or should assist teachers to develop both languages mentioned above. I believe, personally, I believe in phronetic research, which is a type of research that is practical and useful, that aims at improving practice and expanding our knowledge, empowering the teacher and the learner. The ultimate goal of this type of research is to emancipate the mind and to encourage people to think critically and advocate for social justice. So that's my philosophy, and that's the ultimate goal of doing research. Otherwise, why should we engage in doing research? A sample research proposal is referred to here in this presentation, but more guidelines, mainly a rubric, will be shared with you in your Canvas course. So just start working on your literature review and finalize a researchable question to build your research proposal. It must be something that you are genuinely interested in. So think of something that interests you as a teacher or a pre-service teacher or in-service teacher, and share it with me for approval. The basic methodology for quantitative research design, if you are going that route or you are reading about quantitative research, you should have a good understanding of this kind of research. So this type of research, like any other type of research, is based on the scientific method. The difference between quantitative and qualitative research, however, is that quantitative research uses deductive reasoning, where the researcher forms a hypothesis, collects data to investigate the problem, and then uses the data from the investigation to solve the problem and draw conclusions. All right, so just take a look at this and familiarize yourself with the basic methodology for quantitative research, for example. The next slide is where it shows you the structure of research design. At the bottom of the deal, you have the development of a research question or research questions. Then you go to design your research plan, and then you start collecting the data, analyzing the data, and drawing conclusion at the end, and reflecting upon those conclusions to come up with some other further questions for research, and critique your study also by mentioning the limitations of your study and so on and so forth. However, in education, if we engage in what is called action research, we usually follow a cyclical or a helical pattern instead of a pyramid shape. So you start by observing a phenomenon or come up with a question or observation, then you make a plan, then you implement or you apply your plan, then you evaluate it, and then finally you reflect upon it and you evaluate the whole situation. And you may come up with a new observation, and it goes on and on. Okay. The basic steps are basically you develop a research question, conduct thorough literature reviews or a literature review in your case. You redefine the research questions or question or hypotheses. You design your research methodology, and you create research proposal. You create your research proposal. Now, step 6 is required for any type of research that's going to involve human subjects. And talk to me if you are planning to use your students to apply certain ideas or explore some ideas with them in the classroom. Then you collect your data, analyze the data, and you draw your conclusions, and you write your final report of your findings. Research questions by type of research. This is very important because if you are engaged in quantitative research, you need to understand these types of designs. The true experimental design is the one that looks at the measurement of an effect or an impact. I gave an example here of second language acquisition, the effect of teaching with a cooperative group strategy or a traditional lecture approach on students' second language acquisition achievement. A quasi-experimental design would be the effect of preschool attendance on second language acquisition achievement at the end of the first grade, as an example. Correlational research, which is also quantitative, is the relationship between an aptitude test and achievement in a second language, for example. Descriptive studies in quantitative research look at things like a description of the extent to which elementary teachers use scaffolding techniques with EL students. So these are just examples of some quantitative research questions that can be matched with different types of designs. Examples of quantitative research studies, I would refer you to this one, which is very close to you in the program. I conducted with my colleague, Dr. Shinge, a study, a quantitative study that you can find referred in your in your course. Of course, if you'd like to take a look at that, I'll be happy to share it with you. A sample of a research proposal. In this case, when I taught this class 701, I gave them a format and a rubric that they followed, and I will do the same for 720 or any class that I am doing this with students. So for now, continue to research and read about a given area or topic for possible research questions. And feel free to share that through your question answer form. Here's an example of a research study, for example, in this case, if you want to take a look. Defining statistics. Statistics is the science and practice of developing human knowledge through the use of empirical data. So this is something that you need also to become familiar with, not only as a producer of research, but also as a consumer of research. When you read an article, you need to understand certain aspects of research method used in that particular study, so that you can be able to critique it. Here's some humor. A physician makes an analysis of a complex illness, whereas a statistician makes you ill with a complex analysis. If you want more jokes, you can check this link here for fun, okay? Research begins with, when there is a question, okay? It begins with a question. So make sure that you have a very, very good question when you start doing your research. Descriptive questions. How many male ELA, English Language Acquisition teachers, work at Emporia High? This is a descriptive question. How many hours a week do teachers spend working with EL students? Inferential types of questions would be, does the nature of L1 help students acquire L2? What factors most predict success in second language acquisition? It's an inferential. In other words, it's a question that would require use of inferential statistics. These questions would require use of descriptive statistics. They are very simple. Deciding on the kind of stats or statistics to use, I would refer you to handouts, a very handy handout that I will be sharing with you. It will guide you on what type of statistical tests or tests to use depending on the type of data that you have and so on and so forth. So this process is decided by the kind of data that you have and the number of variables you are dealing with. So check it out. Types of statistics. There is, as I mentioned, descriptive statistics and inferential statistics. Descriptive statistics describe the relationship between variables. Examples of these include frequencies, means, and standard deviation. In inferential statistics is the kind of statistics that make inferences about the population based on a random sample. Now we get into in-depth with this, and we go to the levels of data. Data can be categorized in terms of nominal, being nominal, ordinal, or interval. Now, and then I gave examples here for you. Nominal, categorical. Another word for nominal would be gender is nominal, ethnicity, grade level. Data that is classified into categories and cannot be arranged in any particular order. Nominal means categorical, dichotomous, okay? So either male or female. Ordinal data, that's the data that's ordered, but distance between intervals not always equal. For example, you ask EL students to rank their most and least interesting ESL activity. So they will rank them, and that will be ordinal data. Interval data is, it comes in equal distance between each interval. For example, test scores are usually treated as interval scales in language research. Ratio is another example, and I have given you examples here with weight and salary. Types of variables. As you know, and I'm sure that most of you, if not all, are familiar with the independent and the dependent and independent variables. And here's just a quick review for those. Types of variables continued. You have what is called an intervening variable, is the variable that links the independent and the dependent variable. All right, and I have given you here an example, and you can take a look at those. A researcher wants to study the effect of audiolingual method in second language acquisition. Audiolingual method would be the independent variable because it is hypothesized that it will have an effect on second language acquisition, and second language acquisition would be the dependent variable because it is the variable that may be influenced by ALM. All right, so here you go. You have the independent variable and the intervening variable, and then you have the dependent variable. Descriptive statistics defined, and these are some basic terms or concepts that you can familiarize yourself with: the mean, the median, and so on and so forth. And look at that joke again. A statistician is someone who can have his head in an oven and his feet in ice and say that on average he feels great. All right, so one thing that you need to pay attention to here is that the mean can be misleading because it can be greatly influenced by extreme scores or values, okay? So just be careful. So sometimes the median would be more meaningful and has more information for you. What is a median? Again, next slide will explain that to you with examples. So take a look at this and enjoy. Mode, same thing. So you have here on this slide a definition of mode and examples of mode. Inferential statistics are used to draw inferences about a population for a sample. Population means a group that the researcher wishes to study. A sample is a group of individuals selected from the population. So those are just some common terms that you need to be familiar with. Inferential statistics are generally required that they require that the data come from a random sample. What is a random sample? Randomization is a process in which you make sure that you the subjects or the person, the people that you are using or objects or items of the population has an equal chance of being chosen in your study. Goal of statistical analysis. The goal of statistical analysis is to answer two basic questions. Is there a significant effect or association and or difference between the variables of interest? That is to say, can we reject the null hypothesis? And if there is an effect or association, how big is it? This leads us to the next step. So assuming we are dealing with parametric data, meaning that the data is normally distributed, we will use an ANOVA test to compare the results to see if the group differences are due to chance or are sufficient to reject the null hypothesis. We have to be careful though when we use ANOVA. An ANOVA test provides information on whether or not the groups differ, but it provides no information as to the location or source of the difference. That is group 1 significantly different from group 2 or group 3, or is group 2 significantly different from group 3? To determine the location of the difference between F value, when F value is significant, a post hoc analysis is used. And the common post hoc analyses included in this case would be the Tukey test, the Sheffey test, and Duncan's multiple range test. And these types of tests are selected from SPSS program that I will be talking about later. Another example. Um, Parametric tests assume that the variable in question is from a normal distribution. Normal distribution means that the data is not skewed in any direction. Non-parametric tests do not require the assumption of normality. So if you are not sure, you can run a quick test using SPSS, which is a software program that we use at ESU to test these assumptions and to do statistical analyses. Hypotheses. Okay, there are types of hypotheses, and the null hypothesis, examples from TESOL and second language acquisition, and then the null hypothesis is denoted or referred to as by an H with a little zero at the bottom. Okay. Hypotheses, you have the alternative hypothesis, and an example again with second language acquisition. Alpha level or significance level is the value that is determined by the researcher in order to reject or retain the null hypothesis. It is a predetermined value, not calculated. It's something you decide on. In other words, if we select a value of 0.05, findings would be deemed statistically significant if they were found to be 0.05 or less. What does this mean? This means that alpha indicates the probability that the null hypothesis will be rejected when it is true. In other words, the null hypothesis is wrongly rejected. So this is, we talk about type 1 error in research. Okay, so when you see this in an article, you will understand what the researcher is referring to. Type 1 error in a trial of a new ESL teaching method X, the null hypothesis might be that the new method X is no better than the current method Y. All right, so that's an example again. The null hypothesis would be there is no difference between method X and method Y. A type 1 error in this case would occur if we concluded that the two methods produced different effects when there are no difference, where there was no difference between these two methods. Beta. Beta is the probability of making a type 2 error in research methodology when testing a hypothesis. So type 2 error is failing to detect an association when one exists. It's the opposite of the previous error. Or failing to reject the null hypothesis when it is actually false. You kept the null hypothesis when you should have rejected it. If method X and Y produce different effects, and it was concluded that they produce the same effects. Statistical significance. What is statistical significance again? Statistically significant findings mean that the probability of obtaining such findings by chance only is less than 5%. That's why when we selected that 0.05 level, this is what it means in plain English. Findings would occur no more than 5 out of 100 times by chance alone. What if your study finds there is an effect? You will need to measure how big the effect is. You can do this by using a measure of association. See an example of when such measure of association is used in a research article that as I said, I shared with you in Canvas. And see the next slide for more on this. I think I have also shared something here. Here we go. Measuring the strength of associations among variables, an example. So go back to that study and take a look and see how we have done that. And this test that we used, which is Kramer's V value, to measure the associations between and among the variables that we were dealing with. The test represents, for example, in this case, the magnitude of association between the ESOL license and success in the applied linguistics test that was administered to teachers. Parametric and non-parametric tests, refer to the handout in your Canvas course. Again, the handout is entitled Inferential Statistics Decision-Making Tree. That's a beautiful tree. I would highly recommend that you keep it handy in your during the duration of your program while you are still engaged in doing research. And some of you may choose to do a thesis, and that becomes very, very useful. Parametric tests assume that the variable in question is from a normal distribution. So this is very important for parametric tests, that the data should be normally distributed. Non-parametric tests do not require the assumption of normality. Most non-parametric tests do not require an interval or ratio level of measurement, so they can be used with nominal or ordinal level data also. Types of parametric tests, and here's a list of those: t-test, ANOVA, Pearson's correlation test, and linear regression test. Now, this is an advanced level. When you get to that level, I think even in second language acquisition research, I will share with you a guide, and in that guide there is advanced tips, which I would advise you to just ignore for now, because we are not going to go to that level. All right. Types of non-parametric tests. Again, you have Mann-Whitney test, Croskall-Wallis test, chi-square test, and Wilcoxon test. The good news is that you are not required to manually calculate these tests in your classes. So otherwise it could have been a big problem. SPSS, the social package for social sciences, the statistical package for social sciences will do the job for you. For short, it goes by SPSS. You just need to know how to code your data and enter the data into the system. It takes less than a minute for SPSS to generate your graphs and tables. For more guidance on how to use the statistical package for the social sciences in second language acquisition, please check the guide on doing statistics in second language acquisition under your course documents. If it's not there, I will go ahead and upload a copy for you. All right. Non-parametric tests. Use non-parametric tests when all assumptions of parametric statistics cannot be met. They can be used when the data that with the data that are not normally distributed. Normality is, how do you know if data is normally distributed? Run a test or histogram in SPSS to determine if the data meets the normality assumption that is required for parametric tests. SPSS will create a graph to demonstrate the normality and this distribution of your data, that your data is not skewed, as I said earlier. Types of analyses for one variable. Here you go. So if you are dealing with only one variable, you can just use descriptive statistics and you are fine. Okay. If you are moving with more than one variable, then you will be considering some other tests, and I have listed for you some examples of bivariate analyses, which include Pearson's correlation t-test, Spearman's row, Mann-Whitney test, and linear regression. Multivariate analyses also include things like the multiple regression and multiple logistic regression. Chi-square test is one of them also. Research examples. Example 1, univariate analysis. Here's an example of some research questions. How many ELLs speak Spanish as an L1 in Emporia? So it's only one variable. Two variables. Are L1 proficiency and L2 proficiency levels correlated? Another example with multiple variables. Do age, motivation, learning style, and socioeconomic status predict second language acquisition reading proficiency? So there you go. So you have multiple variables. Assumptions. Now, selecting the appropriate statistical test requires several steps. The level of variable, the type of data that you are dealing with is one thing. And you need to test the test selection should be based on what is your goal, the description, the comparison. Are you planning to do a description or a comparison or a prediction? Are you interested in quantifying the associations or prove effectiveness or prove causality? So all of these things are going to determine the type of assumptions that are behind a certain test. What kind of data have you collected? Is your data normally distributed? Can you use parametric or non-parametric tests? What are the assumptions of the statistical test you would like to use? Does the data meet these assumptions? Again, these assumptions are described in SPSS guides and so on and so forth. And assumptions again continued with some examples. So take a look at these notes, and if you have questions, you can always ask me. I'll be happy to address them for you. All right. Examples of tests. Again, t-tests. And here is a description again of those. It allows the comparison of the mean of two groups. It compares actual difference between two means in relation to the variation in the data. And here's an example. A teacher uses two different methods to a group of EL students to see if second language acquisition proficiency levels differ and if the differences between students are in fact significant. Here is your null and alternative hypothesis. Examples of tests. ANOVA is an example. Allows you to compare comparison of three or more groups. It looks at the variation within groups, then determines how that variation would translate into variation between groups. If observed differences are larger than what you would expect by chance, the findings are statistically significant. For example, here you have an example. Are TPR, which is the total physical response, and audiolingual method and phonics method equally effective in teaching ESL pronunciation? So this is just an example of a research question that includes multiple variables and different groups in that case. Correlation is another one. So one important thing about correlation is this important note. Correlation is not causation. Many people confuse that. What is the relationship between age and motivation in second language acquisition? Does motivation increase when age increases? Does motivation decrease when age increases? Is there no significant correlation between the two? And so on and so forth. So, but the thing that we need to remember is that this correlation is just a correlation. It's not the causation, and that's very important. Some more examples of tests. Again, linear regression focuses on prediction. It involves discovering the equation for a line that is the best fit for the given data. That linear equation is then used to predict values for the data. For example, do variables A and B predict event C? For example, does the nature of L1 and L1 proficiency predict L2 proficiency in this case? So that's an example where linear regression will be used as a statistical test. That'll be it for now. I look forward to getting some feedback from you with questions, and also most importantly, I'm looking forward to reading your research questions. Take care now. Bye-bye.